The technology is exciting, though it still has to deliver much more on the hardware and software fronts to gain traction. VR challenges include missing engaging content, overcoming nausea problem, high cost, the imprudence of cables and devices on a head. On the other hand, many entrepreneurs and tech fans are super thrilled about VR, expecting it to grant out-of-body experiences. 100% converted and certain that virtual reality is the next big leap, many of them have started producing VR content. So what is VR and how does it work? What is its potential and which VR producers should you follow? What is VR? Virtual reality, VR, is a brand new user interface unlike the conventional one, immersing a person in a digital 3D environment, instead of watching on a display. Computer-generated imagery and content aim at simulating a real presence through senses, sight, hearing, touch. Virtual reality simulation requires two main components, a source of content and a user device. Software and hardware, in other words. Currently, such systems include headsets, all-directions treadmills, special gloves, goggles. VR tools should be providing realistic, natural, high-quality images and interaction possibilities. For this, devices rely on measurements like image resolution, field of view, refresh rate, motion delay, pixel persistence, audio-video synchronization. The main challenge of VR is tricking the human brain into perceiving digital content as real. That is not easy, and this immersion issue is what still holds virtual reality experiences back from being enjoyable. For example, the human visual field doesn't work as a video frame, and besides about 180 degrees of vision, we also have a peripheral vision. Yet, the VR visionaries are confident of overcoming such issues sooner or later, campaigning for the concept and collecting investments in millions. The virtual experience like 360-degree videos and pictures, VR apps and games, are already available. There's a good enough choice of headsets as well. For more basics of VR, and how you can explore it, watch this dope and simple explanation with fun facts along. How does virtual reality work? As mentioned, VR requires several devices such as a headset, a computer, smartphone or another machine to create a digital environment, and a motion tracking device in some cases. Typically, a headset displays content before a user's eyes, while a cable HDMI transfers images to the screen from a PC. The alternative option is headsets working with smartphones, like Google Cardboard and Gear VR, a phone that acts both as a display and a source of VR content. Some vendors apply lenses to change flat images into three-dimensional. Usually, a 100-110 degree field of sight is achieved with VR devices. The next key feature is the frame rate per second, which should be 60 FPS at a minimum to make virtual simulations look realistically enough. Valentina Shin from the Computer Graphics Group at MIT explains it all nicely. For user interaction there are several options. Head tracking. The head tracking system in VR headsets follows the movements of your head to sides and angles. It assigns X, Y, Z axis to directions and movements, and involves tools like accelerometer, gyroscope, a circle of LEDs around the headset to enable the outside camera. Head tracking requires low latency, i.e. 50 milliseconds or less, otherwise, users will notice the lag between head movements and a simulation. Eye tracking. Some headsets contain an infrared controller that tracks the direction of your eyes inside a virtual environment. The major benefit of this technology is to get a more realistic and deeper field of view. Motion tracking. Though not engineered and implemented well enough yet, motion tracking would raise VR to a totally new level. The thing is, that without motion tracking you'd be limited in VR, unable to look around and move around. Through concepts of the 6DOF, 6 degrees of freedom, and 3D space, options to support motion tracking fall into two groups, optical and non-optical tracking. Optical tracking is typically a camera on a headset to follow the movements, while non-optical means the use of other sensors on a device or a body. Most of the existing devices actually combine both options. VR, Mr., what's the difference? Knowing what is VR is not the full picture of the tech world today. Virtual and augmented realities are very similar and often the line between them is very thin. R appends the real environment with a simulated one, overlaid on top. Augmented reality applies algorithms and sensors to detect the position of the camera and then superimposes 3D graphics objects into a user's view via smartphones, glasses, projections. One of the ways to describe the difference between VR and AR is to compare scuba diving and visiting the aquarium. Virtual reality would be like swimming in the sea along with fish, while in augmented reality you'd see a fish popping out of a pocket or a hand. On the other hand, unlike VR, AR offers users more freedom of action and doesn't require a head-mounted display. The term mixed reality is often mistaken for augmented reality. But actually, mixed or hybrid reality is a more sophisticated kind of technology, where AR is a subcategory of it. It includes non-commercial applications like military simulation-based learning programs, virtualization environments for manufacturing, healthcare, aviation, etc. Major VR market players. The number one is, of course, Oculus Rift virtual reality headset. It is a small, well-crafted device, requiring a connection to a computer. A user can either sit or stand while playing a game, though it is somewhat limited in movements. With dozens of thousands of units being sold each year, Oculus stays at the forefront of the VR hardware niche. Other honorable mentions are Microsoft HoloLens, in contrast to Oculus Rift, uses holographic technology, therefore often marketed as augmented reality rather than VR. It gives the user an opportunity to interact with holograms around him. HTC Vive, also famous for developing the Steam platform for gaming, Vive by HTC is the first headset for Steam VR products. Samsung Gear VR, using Oculus head tracking technology in combination with Android smartphones, e.g. Galaxy Note 4, to power mobile VR experiences. Its lenses basically transform a phone's screen into a stereoscopic screen. Google Cardboard, the simplest and the most affordable VR headset. A device for Android smartphones for something like $15, with a variety of games and mobile applications available from the Play Store. Google Daydream, the advanced version of VR headset by Google, working with smartphones, and a standalone version with controllers coming soon. We have a full separate post on the best VR headsets, that you can freely check as well. Areas of use. Virtual reality has the potential to make new discoveries and have a positive impact on multiple areas of our everyday lives. When it's too dangerous or expensive to try something out in reality, VR is a great option to have. Think of training aircraft pilots to surgeons, and areas like education, training to acquire certain skills, science, visualization of data and research, medicine, monitoring, training, diagnosing, industrial design and architecture, gaming and entertainment, immersive and interactive experiences. If the cost of VR becomes lower, it can go more mainstream and there could be even more uses. VR can make the technology more humane. It can be both entertaining and scientific. Will it overcome its challenges and limitations in the future? We will see soon enough.